Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, Matt.
Hey, I'm John.
And this week we're kind of look at machine learning. The machines are learning what we're doing. In the grand scheme of things. Where we're getting kind of into the world of where your machines are doing, where your software and servers and stuff like that is preparing your preventive maintenance for you if you're looking at the OT side. Or from the IT side, it's looking at your code. It's validating your code and kind of seeing that, okay, cool, I've seen this combination 15 times before. You're going to fail at line 30. Just because I've seen this, so many times before. You haven't gotten any better at doing your code, so we're just going to tell you it's going to fail at line 30 for the 30th time that you've written the same damn thing. So it's, getting there. It's like the machine learning stuff is one of those where it iterates us into the future of manufacturing and the future of IT, the future of drone technology, because you can use it for, recognizing different tactical vehicles and stuff like that that are on the move. Amongst other things. And then also you start dealing with like some of your facial recognition stuff. If you really want to get into that process. Yeah. But, I'll turn it over to y'all. When you start hearing machine learning, what are you thinking?
So that's a great point to start at, because if you asked me like literally 20 minutes ago if there was a huge difference between the two, I would have said no, because a lot of people view it very similarly. To me, I needed you guys to show me the distinction. So Ed, do me a favor. Explain the difference between the two, and I guess I can kind of take back over and kind of explain why I thought they were kind of the same.
Okay.
So yeah.
So if we started with machine learning is basically, for example, when you use a linter, just to follow up on what Nick was saying about code, the reason the linter knows when you're doing something where it can auto-complete is because the linter has a predefined library that's already been defined. Mm-hmm. So it knows when you type in, say, PR, that more than likely you're going to use print. Say if you're using Python and you use tab. Mm-hmm. So it's an efficiency tool. So they've taken people that have typed in these millions of codes. For example, when you do quotes, instead of you have to hit quotes twice, it knows when you hit quote to either give me single quotes or double quotes, depending on what you do. So that's machine learning has taken basically, we could say, like a library. Mm-hmm. Then that library has been played over and over like a playbook, and machine learning has learned those tasks. AI is a little bit different. AI is it's a higher level. AI does have to be taught, but once you teach it, it starts to learn for itself. So the algorithm starts to not necessarily write itself, but the algorithm starts to say, oh, okay, well, we did this, so it starts to make assumptions. And then those assumptions is how it learns. Hey, did this or did this not? So if-else. And then with those if-else paths, it starts to learn what to do. And machine learning and deep learning is behind that. But for the most part, a human has to do the initial teaching or the initial coding.
So that's exactly what I was going to kind of just circle back to. So machine learning, your computer, your application, whatever system, is learning from the algorithms or the inputs from you, a human, some user or whatever, not another computer or anything like that. The second it becomes another computer, or the second it becomes itself, like it's teaching itself, that's AI. So that to me made it very, very clear the line between the two, because I've always kind of used them synonymously, really, and I bet you a lot of people honestly have, because they are under the same realm but different complexities. So I mean that makes sense to me. So that, like, going back to what you're saying, that's where I would start, and honestly that's the bread and butter. There is, you just learn from there. I mean, just like a baby would, right?
Yeah, and if you think about it, how many of us have been using machine learning without even knowing we're using it? That's the other thing. Is if you think about it, Google Complete, when you're using the search function in Google, it's auto completing, information. It's remembering the 1,000. If you look up the most searches, like Google AdWords and stuff like that, it's going to tell you what all the searches were ever compiled, because it takes all of that Google Analytics, throws it in the database, and spits it out on the other end.
And that's the key.
Yeah.
The databases are actually the thing that's in the background with the deep learning.
Yeah.
Those are databases that are being accessed.
So you need to say, you need all of your data points in order for this machine to continue learning.
Right.
Or you need to clear up enough space for this machine, if it's learning on its own, to be able to adjust.
Right. It's like if you take there and use a system called TinyML, and you hook TinyML up to a camera, and that camera takes a picture or something. It's gonna take that picture, turn it into a 2D image. It's gonna send it through its database of all the different images it found, and eventually spit you back at a match. That's where it comes from. It's like, for instance, if you take a drone footage and you tie it to TinyML, and you fly it over, for instance, right now, Ukraine, and you take a picture of a Russian fighting position, or in any other war, anybody else's fighting position. Right now, it's just easier to pick Ukraine. We take a picture of that. It's going to tell us exactly what vehicle that is, because some software has had more and more images compiled into it that gives you a bigger data set that finally narrows it down and says, okay, cool, I think this is a T-72. Or this is a T-82. Or, hey, I haven't seen this before. I don't know what this is. Or this is an Icelander freaking missile system. I know what this is. And then the thing is once it figures that out, it can tie that to an impact range. It can tell you just how much damage that's going to do. It's like you can take also, machine learning and tie it into like the explosive ordnance disposal, type of world when you're starting to deal with explosives. You start dealing with that type of stuff, and you start turning it into, okay, cool, I have this explosive. What is my blast range? And it automatically spits out your blast range, shows you a map, via GPS. There you go. That's really not in use yet, but something out there. It's available. You take a picture of the barcode, it searches what it's looking for, and out it comes. If you're dealing with like HME, homemade explosive, you don't have that option anymore.
No.
Well, I mean, following up on it, we was talking about AI or machine learning. We would say machine learning.
Yeah.
AI still is really in its infancy, but the concept is
the concept's there, yeah.
But machine learning, we can go all the way back to auto correct.
Yep.
In Word.
Or on your cell phone when it doesn't make any sense.
Yeah.
Like spell checker.
Spell checker, yeah.
And then Quillbot.
Yeah.
Quillbot is a application that you can use on the web that you type in your information. It does a grammar check, so it'll check for punctuation and those things and point out the errors. Then you can correct those errors. Then you take that and say, well, hey, I want to summarize, or I want to paraphrase this, and it'll paraphrase.
Right.
Based on a couple of predefined sentences. And then you can go in and even click on certain words and say, well, I don't want this word, I want that word.
Right.
So, I mean, these are things that are doing machine learning, like you're saying. Weather stations at home are using machine learning.
Most of them
smart watches are using machine learning.
Google Lens, when you're taking pictures.
Google Lens
of stuff like that. So you can translate, Google Translate, when you're taking pictures of menus and stuff like that.
Yeah.
That's using an onboard machine learning algorithm.
Yep.
That kind of tells you what's going on. I just wish for us, happier people, they would tell us what the calorie count is of the food that we're trying to eat.
Yeah.
We'll get there.
We haven't got there yet. It's possible. It is possible.
And also,
I bet your Weight Watchers is working on it.
you
Probably.
talk about the machine learning. What about the machine learning on vehicles?
Oh yeah.
As far as the sonar systems that they
Yeah,
have now that
yeah.
can kind of calculate the distance between another car and figure out, hey, this is the best route to go if something cuts you off or a person's come in front of you. Now the car stops.
Yep.
Yeah, I was gonna say like when
Like
you
the
talk
Tesla
about
self-driving
GPS,
stuff.
Oh yeah, self-driving or like my app. I use Waze when I like navigate. It'll update me
More than they should.
with more than that should, whatever. It'll update me with traffic patterns, and those are inputs from other users that are using it. So they're like, hey man, I've been on this road for a while. They're like, yeah, this other user's using it for a while. He's not moving very fast. Are you in a slowdown? And based on what your input is, it'll update the traffic, reroute you, or just tell you this is still probably the best route.
Yeah, you're still stuck in traffic. Sorry, my
Sorry,
bad.
man. You're gonna have to tough this one out. but still, it's learning, and I bet you most people. Back to your question is how many times we use it. I bet you everybody uses it almost every single day.
It's a guarantee.
Guaranteed. Now you're absolutely right. AI is in its infancy, and we can probably spend a whole episode just talking about AI. Just explaining what the difference was, though. You've taught me that I've been using something called Mid Journey, which just creates like artwork based on your prompts, and you just taught me that it's my prompts. I have to put these things in. Now the computer probably uses like a baby version of AI because it's trying to formulate whatever your word means in a picture or a visual sense. But yeah, I think it's dope, and I think that like we should use it pretty much almost in everything.
So,
Yeah.
to go back to what you're saying with machine learning, think about it. I have a furnace.
Yeah.
I have to put the coal in the furnace. But once I put the coal in the furnace and it ignites, then the flame itself does the work.
Yeah.
It's the same thing with the AI. Once the initial inputs are put in from humans or coding from humans, then the AI starts to learn. The AI says, well, you know what? This person said sunflower, and this person said sun and flower. Oh, okay. So did he mean flower or did he mean sunflower? So now the machine starts to distinguish between what the input was. And then, okay, so maybe because I got 100 of these inputs that were just sunflower, they want something based off of sunflower with something.
Right.
Or maybe it means the pieces of that word. The sun and a flower. So I want a combination of an image of a sun and an image of a flower.
And it takes into account, localization. Localization issues. Where some words and phrases are not said the same exact way.
Correct.
You got some countries where it's a noun before the verb, a verb before the noun. You never know what you're gonna get.
Or the word doesn't exist.
Right. Exactly. And that's the type of stuff you're dealing with. It's like I cat. What? It's okay. Well, let's figure this out so we know what they're saying. So you get I have a cat. It does that translation for you. If you ever used a social media, for instance, and one of your friends writes in a foreign language,
Google does it a lot.
yeah. Love y'all, but Jesus Christ, you have to translate stuff. So or you have to figure out how to read it yourself, which that's usually what I do. But or you get sent a document and you get said, "Hey, can you read this for me?" Great, translate.
Yeah.
Because it's the only thing you got. At the end of the day.
Yeah.
But the thing is sometimes the language doesn't really match up. I've dealt with a lot of countries where the language just doesn't match up to what you're trying to tell me here.
Yeah.
But especially if you do like a translate, you're like, ooh, that's not right.
Yeah, it's just for us. Words mean different things too.
Yeah,
like
right.
they can be synonyms, but have very different weight, like necessary and required.
Yeah.
Like both of them to me would mean that you need this.
Yeah.
But if you said required, I'm not gonna make it without this. You said necessary, I could probably squeeze this one by.
Well, it's also if you think about it, some cultures out there, they write right to left, left to right.
Yeah, that's true.
Listen,
I'm learning German, and
so,
it is a struggle.
Like for example, in Middle Eastern countries, Afghanistan, Iran, Pakistan, and stuff like that, a lot of writing goes the opposite direction.
Yeah.
But it's right for them, wrong for us. But so when you use a U.S. based translator, it kind of flip flops some things. You got to take into account that okay, cool, this might be a little wrong. But I've had friends who they're from Afghanistan, Pakistan, that part of the world, and they've looked at some of the translations and said, no, it's actually pretty accurate. It does pretty well. Oh, okay. You never really thought that you'd see Pashto or Dari or any of those other languages being translated by a Google machine that that spits out the languages at the other end for you.
And
mind you, if you try to learn that, if you're really good at learning Pashto or Dari, I give you props on that. I've learned it a long time ago, and I still have problems with it.
There's probably a lot of examples going through there, so like it's just the best place. And honestly, if we as humans work out the best translator for everything, like I think that would be pretty amazing in and of itself.
Well, have you ever seen this is going to go down this rabbit hole, and I knew that we were headed this direction.
Yeah.
When I started talking about translators, it's the earbud translators. Have you seen this? Like you would wear an earbud, and I'd wear an earbud, but I would talk to you in German, you'd hear it in English.
That's cool.
Or you could talk, you could talk to me in French, and I'd hear it in German. It just depends on what you have your phone set up to.
I've seen a telecom system like that.
Yeah, now they have the ones that you wear the earbuds in both ears,
Yeah.
and you can walk through stores and you can have conversation with people.
Yeah.
Is it always accurate? Who knows? But the thing is that's portable machine learning that you're wearing in your ears at that point.
Yeah, I mean, it's definitely a rabbit hole. I want one, but it's once I heard, that's the whole reason that I don't like marshmallow earbuds is because you honestly should be aware of your surroundings almost always.
Yeah.
Am I going to get hit by a car?
Yeah.
Now the option is more likely if you're walking across the road, but you could still get hit by a car off of road, so you should kind of be paying attention.
Yeah, depending on what country you're in.
Yeah, right. That's true. So I'm just saying. I think that's a good use of it, but we struggle a little bit.
But I'd say this.
Sensory issues.
Just to follow up on that, and then to move on to a different perspective. If we're able to take that technology and translate, then we should be able to use geolocation or GPS and have some kind of system set up, sonar or whatever, to say, hey, or if you want to say spidey senses, so that they know that, hey, you're about to walk across the road, I'm cutting it off.
Yeah.
And when we get on the other side of the road, I'm cutting it back on.
Right.
But the other perspective I want to talk about was spam filters.
Oh yeah.
So spam filters are now using machine learning. I mean, it's not the best because
I should work on myself.
the threat actors are using the same technology too and trying to pivot and leverage with these things. But we also have next gen routers and switches.
Mm-hmm.
Which can automatically route information into a sinkhole,
right? So
that you can do analysis on that and understand what the threat actor is trying to do.
Mm-hmm. It's like if you think about it, you got machine learning now that is on board, like for example, the like Mars rovers and onboard satellites, circling the moon. Looking for landing sites for the next Artemis generation.
All of the telescopes we have.
Right. It's like we just entered the Artemis generation. We entered a long time ago when we sent Artemis up on on its main test flight. But now that we've launched Artemis is now outside the circumference of the Earth and has passed around the moon. And we've seen some really good pictures coming back from that though.
Mm-hmm.
Some outstanding pictures. But the thing is they're having to use machine learning on the explorers and stuff like that are out there right now, on the satellites that are taking pictures of the moon, trying to figure out where to land. Is this right size? Is this the right size based on this geometry that I'm given? It can automatically tell you, can you land on the dark side of the moon? Can you land on the front side of the moon? Can you land? Where can you actually put down at? If you think about it, we're using machine learning in so many different ways. Like you said, the telescopes. We're using onboard James Webb.
Yeah.
We have them on there that says, okay, cool. I need to fire this rotation just a little bit to get in line with where I'm going. Maybe I need to pull away a little bit because I'm in the sun a little bit too much. I'm going to start cooking things. Bad things happen. And it does it all on its own.
Yeah.
Yeah, they definitely got those like pictures and those like areas because they've got to focus all of those mirrors they need something piloting it, and those minute changes, like of course, that just makes sense to be used with machine learning. Otherwise, you can't focus enough light to get the proper pictures. So, yeah, machine learning is going to be definitely at the forefront, the bleeding edge of technology. We can kind of bring it down to earth. Like machine learning, and I know we haven't brought up 3D printing in a while. Machine learning and 3D printing is probably already begun in the most parts. So for me, I think I would also like to see some growth in machine learning as far as auto corrections on some like maybe flow rate or printing issues. Well, that would be pretty cool.
Speaking of that, you and me both run Clipper. You and me both run the firmware subset Clipper.
Yeah.
However, we can also tie into a machine learning based system off of the webcams that we use to monitor our systems that'll tell you if you're getting spaghetti detection.
Yeah, we talked about this. I remember this.
So you're getting spaghetti detection, and it has to learn it. So pretty much, like, it has to know that, hey, you screwed up this print like 5 or 6 times. So now, hey, guess what? Now I think I found your spaghetti. Or it uses this, what spaghetti looked like or failed print looks like from other users to determine, okay, cool, that's a failed print.
Analyze thousands of hours of spaghetti.
Yeah, thousands of hours of failed prints.
Failed prints,
right? Yeah. It's 1,000 hours of the new guy.
Yeah.
You know, it's just, really just ignored me. Believe me, I got bags of it.
Yeah, I won't say you're a new guy yet.
But
still, I mean,
we
still got a new guy. But
I understand what he means by the machine learning.
Exactly.
The machine learning is the same thing when we first went from mechanical typewriters. So we went to electronic typewriters.
Yeah.
And it knew how it tapped itself back when you got to a certain point.
Yeah.
So what Champ is alluding to is that, okay, it's great that I have this camera that's getting all these images.
Yeah.
And imaging is funny because it takes up a lot of space.
Yeah.
Quickly.
Yep.
Especially if you do any type of moderate resolution.
Yeah.
High resolution, good luck.
Yeah. Anything over like 1080p and you're screwed.
Better be a short video.
But imagine if a motor that's driving, say a stepper motor or servos or whatever you want to use was able to have that type of learning where it knew, hey, this belt's slipping. Hey, this here's a tricky print, and I only got so much direction X, Y, and Z.
Yeah.
Yeah, it's only so much I can do with the resolution I have.
Yeah.
And then you can also look at like temperature, PID. The PID could start to become machine learning, and then you could, hey, this material over time, is this, and this type of heating bed and element over time at this rate, say 3 to 6 months, if I'm running at this temperature, ABS temperature, then I will have some type of deflection in that bed.
Yeah, I can see that. And, the thing is that kind of takes us into, from a 3D printing thing, talking about the servos and stuff like that we're getting feedback from, is more or less moving into a more industrial an industrial standpoint of where we are getting that fault data, sent over MQTT for certain things that, then we can take like other systems, not really TinyML, but like Python and stuff like that. We can read through that data, or Kibana, for instance, because Kibana has their own machine learning system built into it. You just feed the beast, and the beast tells you what's going on the other end. However, it's like, if you think about it, if we can get more and more advanced sensors on board these drives, like, not really calling out any vendors, but I know Lenza has one that has that ability on there. But their ability to tell us, kind of what's going on. I'm overheating. Okay, cool. Why are you overheating? Okay. Well, I'm overheating when I'm doing this process, or when I have this voltage applied to me, or I'm braking like this. So it's kind of it's giving you preventative maintenance that, okay, cool. Now I know if I'm inside this area, I need to tune that throttle down a little bit, because for some certain reason my belts are pulling too tight and it's overheating my motors.
Or I didn't size the drive and the motor are not sized appropriately.
Right, and it kind of tells you kind of what's going on. For the maintenance guys, it's a game changer. Well, it's what is it? What is it from a maintenance engineering standpoint? If you knew, and you had in your 30 plus years of experience with this stuff, if you had that machine learning ability on the equipment that we have now and the equipment back then, how easier would that make your job when you know you had to replace something?
You would be a lot easier because then you would be more you would be proactive in how you would do things.
Mm-hmm.
So you would know that so many cycles, because it would get down to a cycle count, or it would get down to this vehicle weighs this amount of tons compared to this vehicle, or this vehicle has a length of this compared to this vehicle, or we've increased the tack, and by increasing the tack, we've added more load, or we've added more stress to the motor and the drive.
I can see that.
But you would know that ahead of time. You would kind of be able to proactively. You would actually be able to predict instead of being preventive. It would be predictive maintenance. You would be able to say, I know that if we keep running this motor this way for these amount of hours, this motor will fail here.
Instead of being reactive.
And if I can't, because of production limitations, because the business must run, then we can at least plan the failure. So it could be a planned failure. Have everything ready in place, and then it'll be just a swap. It also be like NASCAR.
Yep.
Yeah.
We just swap tires out, swap the motor out, drive out, go.
Yeah.
But you could have everything prepared because you know that this device is in a critical point. Or you would say, okay, here's what we can do. This device is struggling. How about if we install another device in tandem with this, and then we'll run this at a duty cycle of this, and this at a duty cycle of this, maybe cut the duty cycle in half for both, and then you reduce the strain until you can replace that device. So there's some things like that you can do. So engineers would have an opportunity to use those tools to start to be more flexible.
Yeah.
And with cloud-based computing now, whether you like Azure or whether you like AWS, those things are also using machine learning.
Because if you think about it, and this is just gonna take this topic and kind of just bombard it real quick. If you have a single company, okay, and you take all of this data, all of your drive data, all of your robot data, all your plant data, from every single plant you got, it's all gonna be the same language. Throw it into a pool someplace, and you feed off of that pool as one big giant maintenance system.
So basically a historian.
Right, like a historian. But every single plant's responding back, so everybody sees what everybody else is happening.
Yep.
So, if you have a plant that's been running at their same location for 80, 90 years, you have the experience of their guys that are inputting data into these machines. It's cool. Okay, cool. I'm seeing all this. So what'd you do to repair this? Well, this. Okay, cool. Now you have 80 plus years of experience, 90 plus years of experience. These guys retire, and guess what? Now you still have their experience in their hands.
Yeah.
But if you take all that data from all these drives, it says, okay, cool, I know that this drive at plant A, B, C, and D is going to fail on this day. I understand that this robot at this plant is going to fail this day, and this gripper is going to fail this day. So let me go ahead and up my production volume at this plant for that one day to cover for that downtime.
Yeah. And that's center of trust is what you're talking about.
Right.
So a center of trust, basically what they can do, not only does that data go to the manufacturer that's producing, or the OEM that's producing something, I can take this all the way back
to the supplier
and say, hey, here's what we're seeing.
Right.
And the supplier in real time
can make changes.
Can get rid of the design flaw.
Yep.
So if you found a bug, that bug could be eliminated, on the fly.
Yeah. If you think about it, there is actually a company, to what I read the other day, that is going to be building their satellite and space craft manufacturing facility at the launch and landing site on board Kennedy Space Center. It's going to be at the on the landing strip and stuff like that, or over by it. However, this entire organization is going to be run by no other than AI and machine learning. Your entire system, the entire plant's going to be run by that. That's how they're going to determine what their volume's going to be. The temp depends on what their daily volume's going to be. It's going to tell you what they want to do. It's also going to assist with their maintenance components and stuff like that. It's going to know in real time what's going on. As plants grow and we get out of, I guess you could say, out of the automotive world, we start getting that, that trust fall system that we've got. It would be nice to see it show up in the automotive world. It's just going to take a couple decades, because for some certain reason, all automotive OEMs do not like using technology that's somewhat current. Unless you are some more startup-based automotive manufacturers who have actually, embraced the technology. You could say more of the traditional guys aren't going to go that route unless they have to. More of your startup guys are going to go to that, like machine learning inside cameras over the line that tells you if you missed a weld or something like that. I can see everything that's going on.
Because those guys want to be competitive.
Right.
But this is not new technology. The oil company have been using it for more than 20 years, and it's called down the hole data.
Right.
And they've been measuring pressures and the current and all that type of thing when they're drilling, these holes for the oil industry. So it's, matter of fact, they were the ones that embraced the MQTT.
Yep, they came up with it.
Yeah.
Yeah, and it's just
I didn't know that.
Yeah, that's where the down the hole data is what they use, and that's how they predict how long a drill can drill before it breaks, or before you have to replace the tips on it, or things like that. The pressures in the hydraulic lines and stuff like that, the cooling temperatures. They're monitoring all this stuff.
Yeah.
Imagine if automotive companies had started this 20 years ago.
Right, and the thing is, if you think about it, they used to send all that stuff up through through satellites and stuff like that, and bring it right back down. They can take a look at it that way in other parts of the world. Yeah. So you have control rooms for these drilling rigs, stuff like that. They don't have to be co-located with their locations anymore.
Yep.
And that's the MQTT side of it, but it's also the side that you have some of this machine learning stuff that's actually doing it for you and kind of seeing what's going on and can adjust those pressures and tell you, hey, guess what? You're about 2 bar too high here.
Yep.
Let's tone this back a little bit. Okay, cool. I see you're making more progress. Let's go up a little bit on your pressure and on your coolant lines.
Probably gonna end up saving them money too.
Yeah, if you think about it. Yeah. But there you go. If you think about it, machine learning can save you money. How much money could you save if you can prevent 95% of the problems you're going to have? It's like you were saying with the machine learning and in 3D printers. How much money can you save if you knew that was going to screw up in filament?
How much time can you save?
Right.
Just period.
Well, time is money, money is time.
Yeah, so if you compound those two, it's, invaluable. Like there's no number I could place on how much I would need that. So
if you save 2 or 3 spools a year,
it'll pay for itself. And not only that, it's continuously building its own value, but every time it saves you.
Right.
So, I mean, that's I don't see the point in not using it, right? So, I mean, that probably goes like twofold, tenfold for every other, industry. You've got all these sensors already. You've got sensors that are just, they're saving this data for what, like a day, 2 day, a year, and then throwing it away, not doing anything with it. There's your machine learning data endpoints, entry points. So it's not easy to do, but I think it's something that most automakers need to embrace. Otherwise, they're not going to continue to increase production. Yeah. So, especially with everything going into the EV wave, or the let's say carbon neutral wave, if they don't adjust, they'll start slowly dying.
Yeah.
So, like you were saying, like the sensors are there, but you also can use conventional sensor with smart I/O devices.
Exactly.
And then that can be leveraged with MQT, and then you use unified namespace. And like Nick said, hey, I only subscribe to this topic. I don't care about nothing but am I less than or greater than? If not, I don't care. I'm only doing it. I only want the information when those parameters are in effect.
Yeah. And it's like, if you think about it, I watched something the other day, on YouTube, about the new Rivian Amazon delivery vans. They have, in their head units, they have machine learning ongoing, telling you kind of what's going on per vehicle. It's already doing all that data for you. It does, using AWS, of course.
Like telling you where the other vehicles are, or telling you...
And also telling you if you can fit in a parking space.
So is it whenever they're like trying to tell you and they're tracking, they're like, hey, you are 10 stops away. Yep. That's them trying to get you involved in that as well.
Right. And the thing is, that's coming straight off their vehicle.
Yeah.
So, and the thing is, if you think about it, they also have the overhead camera that would looks at the vehicle and tells you if you can fit in the spot or not.
Yeah.
It says, nope, you can't fit there. Too fat. Try again. You know, and you can go down the way, and you finally find a place to park, or this is an unsafe parking area. You know, the machine knows it, and it's telling you kind of what's going on. However, those the head units and the cameras are designed to learn as you do your route. And then as everybody drives that route, day in, day out, it's always a different driver, they kind of learn what that city's about. You know, if you think about it, if you really got bored, you upload a freaking thing from, you know, Google Maps, you know, and up it comes, and guess what? Now you got the entire city in your hands because you got Street View.
Yep.
You know, it's just a little different if you want to read it that way.
And that was human data that was gathered to where it learned that, hey, these are the things in conjunction with GPS coordinates.
Yep.
So data with data.
Yeah. And it also, you know, and the thing is I was also watching the fact that it knows it knows based from your phone, because your phone syncs to the head unit, you know how many stops you have left. And so the vehicle knows based on rate of travel, the amount of delivery stops it has, historical data and knowledge, how long it's going to take that driver to get you your package from point A to point B to point C, and it tells them how long it takes them to take that route. Think about if they give that to freaking FedEx and UPS. We'd stop waiting until freaking 9 p.m. at night for someone to show up.
Well, you're talking about the phone. What about Jesters? When you can do a few gestures on a touchpad, and then it interprets that as a string of letters.
Yeah.
I mean, these are things that's on the phone already. So, like, of course, the phone is basically another PC. You're carrying around a mobile PC.
Oh, yeah.
I mean, it's other functionality there, but basically it's a mobile PC. But, like, just to go back to, just for a second, back to the 3D printer. Mm-hmm. The thing with the 3D printer, okay, so you have a camera that can take the images. But how about if you were able to cross-reference those images to whatever data that's on that electronic board?
Mm-hmm.
That information is there.
Mm-hmm.
If you're able to cross-reference those two things together to make a correlation between why I got spaghetti and what was going on, speed, current, heat, all those things, and then, oh, okay, this is what this picture means. Mm-hmm. It's not just a spaghetti monster. You was going to do this anyway.
Yeah.
So
wrong speed, wrong temperature.
What settings?
Lack of adhesion.
Yeah. Tells you, like, maybe a root cause. That'd be nice. Yeah, that would be really nice. I'm gonna be honest.
Especially for a learner, somebody that's learned, a new person. That would be perfect for a new person.
Yeah, your bed's twisted like it's like a pretzel. You know, it's not even. You know, I'll tell you one thing. Ever since I went to this new Clipper, you know, system, it tells me kind of what my bed level looks like. You know, little by little. So it kind of tells you, okay, cool. Hey, dummy, if you did this, if you clicked on these things and you twisted the knob a little bit this way and a little bit that way, it'll tell you. You know, it'll
how you get back.
Right. This is how you get back to normal.
Yeah.
This is how you get back to zero. You know, so it kind of tells you what's going on. You know, so you got it a little bit in the firmware. You know, that's run off of a Raspberry Pi, but it's not where it can be. I think you can definitely see more if you leverage
Raspberry Pi.
secondary systems on top of it.
Yeah. Like I said, a lot of it, like when you're talking to machine learning, you have to have that initial. Somebody initially has to take the coal and put it in the fireplace.
Yeah.
Or put it in the stove, so that the flames can consume the coal. So you have to have data first, you know, and then it has to be scrubbed. It can't just be data. It's got to be scrubbed and sanitized.
Right.
And then that data has to be vetted. And then once it's vetted, then we know we got an actual data point that we can trust.
Yep.
And then you got to do some analysis. You know, use heat maps and things like that to understand what you're looking at, and why the data looks the way why does this data look this way? You know, so I mean, analytics will come into it a little bit. Yeah, well, analytics come into it a lot.
Yeah, advanced analytics. You start dealing with the machine learning to advanced analytics, and then you start getting your KPIs that pop up on display boards and stuff like that, and it's proven data at that point. Yeah, it's not where it's a wild guess, because some of the advanced analytics stuff out there right now is I fear it's a big wild guess. It's a swag, single wild guess. Mm-hmm. Eventually you'll you it all the time and you throw it up on a board and say, oh look, I think we're here.
But there's a reason that a broken clock is right twice a day.
Yeah. And like throwing darts at a dartboard.
Yep.
Even the guys
In the
that,
dark
It hit the wall.
are superior at that were not always superior. They
Yeah.
were off target a lot before
Right.
they dialed it in. So this technology has to be dialed in.
And the thing is, if you take that and you actually sit there and you compound systems on top of systems, so machine learning on top of advanced analytics and stuff like that, and vice versa, your advanced analytics can help breed the machine learning aspect. The machine learning aspect can help breed the advanced analytics standpoint. There's people out there, they just run advanced analytics stacks, right? You don't add anything to it. So if you don't add anything to it, guess what? It's going to be wrong 99.9% of the time. Eventually you might get right, and you're trusting, nasty, salty data that doesn't make any sense. You never know what you're going to get at the end of it. But, that's just how systems can help systems, correlate. It's like you can use, machine learning for, like, server maintenance and stuff like that to tell you if your servers are running hot, to tell if you're running low on CPU, to do your virus scans for you. That tells you, this isn't right.
Yeah.
Do your storage and, delete out things that aren't supposed to be there, or sit there and delete out things that have been there for longer than 2 years.
Yeah, your scripts that automatically go through and scrub those things, it doesn't know the file's names.
It doesn't care.
Yeah.
Yeah, that's true. It doesn't care.
You can do it by date. Okay, I want to wipe pretty much anything from this date on.
Yeah.
Or this date back. Anything that's been in our storage for 10 or more years, please delete.
Yeah.
And the thing is you can use machine learning to do all that for you. And that's when you start getting into, like, your like your virus scans. Like Crowdstrike, for instance. It's built off of machine learning. It's also built off of their own algorithm, and it can find a lot of things that you don't expect.
Yeah. Like I said, and the biggest thing with the machine learning is the humans have to do the fine tuning, and then once the data points have been sanitized and we rationalize all the data points and make sure everything is legit, then the machine can start learning. So if you put in garbage, you get out garbage. You have to have good data going in.
Yeah. Yeah, I mean, it makes a good point. I don't think that all data should be saved. So, but most of that data, especially if you're in a production industrial or you're trying to do some type of project, anything that kind of helps you get towards their end goal. I mean, humans do it all the time when we're doing trial and error. We call it the scientific method. And your computer, once it starts doing those things and learning from what you give it, the tests you do, I mean...
I also have a different name for the scientific method, but...
Yeah, no, that's not like... It's not PG. Let's say.
We'll just find out.
Yeah, exactly. That's the best way to say it.
I'll say this about the scientific method. It works if you implement it the way it's supposed to be implemented.
Right.
If humans are the people that are doing these methodologies, I don't care whatever platform humans. It's not the platform that's the problem. It's the human that's interfacing with the platform. So if you can't beat a video game, don't get mad at the controller. You can go buy a $1,000 controller. If you suck at playing the game, you just suck at playing the game.
So you mean I can't get mad at a fork?
No.
Just checking. Or a calculator because I can't do math.
I still got mad at my controller.
Yeah, but it's not the controller's fault.
No, I pressed that button.
Yeah.
No, and if you think about it now, here's the funny part. If you think about it, if you start talking about like, if you start thinking about AI, and this is something that we can talk about in the next episode. We talk about AI.
Yeah.
Is the fact that AI is in video games. AI knows when to play harder when it knows it's losing.
Oh yeah.
And it knows when to play that one step harder, or when it just has to figure out how to kick you square right in the crotch because it knows that, hey, guess what? I need to slow you down a little bit.
Yeah.
There are some games that if you cheat,
it knows.
Not only does it know, it kills you instantly.
Yeah. So it's a good. It's funny that you
got smited
because I didn't think about this very much, but you're absolutely right. There's lots of video games, and I mean, if you're a fan of zombies, Left 4 Dead was one of those games that I played a lot when I was younger. They had an algorithm that was controlling the game. Look, it's quiet. It's been quiet for how long? 10 minutes? Usually about 10 minutes they make it this far. They've been taking some time. Here's a swarm of zombies, right? That's
Mhm.
exactly what it's doing, and I was seeing that when I was like, what, 15, 16? I didn't even realize that, but it's definitely happening in the games now, and it's like you could even it feels
Resident
almost
Evil.
like a almost like a hive mind, for all of the quote unquote the players in the game or whoever the computers in the game. It's like a damn hive mind. It's crazy.
Look at Resident Evil.
Yeah.
Look at Final Fantasy.
Yeah.
You know, all of those on the newer equipment. I'm not going to say you're going to see a lot of machine learning on a PS2, on a PS1 or PS2.
Well, I think even some of
I'll be
the
happy
games,
to
because
have it.
remember, it's not the platform.
Right.
It's the company that made the game.
Right.
Because all the platform is doing is playing the information that's on. If you
That's
had
on
a
the disc,
disc,
yeah.
So
I can see that.
Yeah, but I'm not sure which one of those PS1 games had that.
Yeah.
If it was Doom, Doom started out doing some of that stuff too.
Yeah. And
I mean, primitively, but
Wolfenstein, no.
Yeah. Well,
Wolfenstein,
and
it
the
did
thing
too.
is, I think that, that gives us a segue into our next episode, for the AI, we started talking about, AI and, how to pretty much, get ruined on a game. But
AI is scary.
it gets pretty creepy.
Yeah.
But,
it's cool.
I think for, the machine learning thing, I think we hit our major wickets that we really want to touch this week.
Oh, yeah.
And I want to go back and again say, thank you, for everybody who's listening in. We're inching closer and closer and closer to that 1,000 mark. I think we're at 987 now. So we're inching closer and closer and closer. And also, what I would do would start be paying attention a little bit more to what we're saying, because there could be a giveaway coming up, that we're going to do. However, that's going to include the fact that you need to be a listener on the podcast. You get a comment on the video that we're going to tell you to, and you also have to be a subscriber to the YouTube channel. If you're all that, you're entered to win and what we're going to give away. And the thing is what I want to do, and this is going to kind of disagree with a bunch of people, but whatever, is every time we hit a certain amount, everybody gets entered back into that pot. So you have a chance to win again, even if you didn't win the first time. So it gives you a reason to stick around a little bit, and. We'll cover that at a later date, to kind of put that in the back of your head. But, for me, I say thank you. Never thought we'd do this and never thought we'd do this. And now we know we can't do it without you. Keep listening. Leave us a comment on the YouTube channel or something like that. Let us know what you want to hear. We're going to have a couple, good videos coming on there soon. I got to post a couple more. And then also, we have a new toy showing up in the next, couple days that, we'll be doing some videos on and stuff like that. So, and pretty much if you want to see somebody build and look like a complete idiot, building a Voron 2.4 350 kit, come over to the YouTube channel and watch me make an idiot of myself. I'm sure we'll all look like an idiot during that building process.
Yeah.
How many times can we shock ourselves in 10 minutes? But, with that, I say thank you. And, hope we see you here again. I'm going to turn it over to the guys, and y'all have a good one.
Yeah, so I would just like to say we appreciate you guys listening. I would like to also thank everybody that's helped the channel grow as much as it has. It started out as Nick and myself, it was like, hey, we like talking about tech. Normally it was at lunch, and we decided, hey, that might be a good idea to, make something, with that. We brought in Champ, and Champ has done a really great job, contributing and actually pushing and challenging us to come up with new topics. But I would ask anybody that has any questions, or maybe you have a 3D printer question, or maybe you want to know something about slicers, or maybe you want to know something just about electronics in general. Leave us a message, and we'll respond to all your questions.
Yeah, I also want to echo these guys. Very appreciative. Couldn't do anything without the support, and it's nice hearing, or nice having people to listen to me. Honestly, we talk back and forth all day about all this tech, and if we can use it as a platform to kind of get anybody else, help fix their problem they're having, work through a project they have, or learn something new, I'm all for it. So I mean, that's the reason why I was here helping, these two bozos put together some printers, and I'll be here probably for a while longer trying with that Voron as well. So we'll
It's gonna be an adventure.
We'll see. So once again, I appreciate it, guys, and stay tuned for the next.
All right, y'all. Have a good one.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.